Logarithm video number 11. Let's draw the function f of x or y equal ln x. As usual, we have to first we have to find the x here, right? Which should be positive. Second, this ln has this u. Also the ln x should be positive, right? This means, by other words, that ln x should be greater than ln 1 because ln 1 is 0. And that means that x is greater than 1. Where do these two numbers meet? X greater than 0, x greater than 1, they meet at x greater than 1, because if it's greater than 1, this means it's sure greater than 0. So what is the domain of the function? Domain of the function is from 1 to plus infinity. This is the domain. So this is very important. Then we start the limit. Limit of f of x as x approaches 1 equal limit of ln x, ln of ln x, right? As x approaches 1, which is 1 plus, right? Which is 1 plus, because to the right of 1, right? Which is simply substitute 1, it's going to be ln of ln 1. And the answer is ln, what is ln 1? It's 0. And what is ln 0? It's minus infinity. And if the limit at a number, at x equal number, is infinity, then x equal this number is a vertical asymptote. So now the vertical asymptote is not the y-axis anymore. It's not x equal 0. It is x equal 1. Then we find the limit at infinity, at the end point infinity, as x approaches plus infinity is equal to limit of ln x, right? As x approaches plus infinity. The answer is simply ln of ln infinity, and ln infinity, which is plus infinity, right, is equal to infinity. So it's ln, and this is infinity, and ln infinity is infinity again. And since the limit of f of x as x approaches infinity is infinity, this means we have possibility of having oblique asymptote, and the oblique asymptote is a straight line of this equation, right? Y equal ax plus b. Y equal ax plus b. Now we have to go and find a and b, if we can find a and b. Okay, what is a equals to? It's always limit at x approaches, what do we have? Plus infinity of f of x divided by x, which is equal limit as x approaches plus infinity of ln x divided by x, right? If we substitute infinity, we are going to get plus infinity over plus infinity, which is indeterminate form, and that takes us to Hopital rule, right? What is Hopital rule says? It's limit as x approaches plus infinity. We just take the derivative of the numerator over derivative of the denominator. First, it's ln u. The derivative of ln u is simply, the derivative of ln u is simply u prime over u, right? This means the derivative of this over itself. What is derivative of ln x? It's 1 over ln x. It's 1 over, sorry, x. Over ln x, right? Over all of those, over the derivative of the denominator, which is 1. Again, what is the derivative of ln x? This is u. Derivative of ln u is u prime over u. And what is u prime? Which is derivative of ln x. If ln x is u, what is derivative of ln x? It's 1 over x over u, which is ln x. So it's simply 1 over x ln x. And the denominator has derivative 1. And that's Hopital's rule. Just derivative of numerator over derivative of denominator. We don't do derivative of fraction. That's something else. That's u prime v minus v prime u over v squared. That's something totally else, right? Now we substitute infinity. It's going to be 1 over infinity, and the answer is 0. And if the limit, if a is 0, if the limit of x over x as x approaches infinity is 0, I did in one of the videos those limits, you can go back and see it. This means directly we can say that the x-axis acts like asymptotic direction, is an asymptotic direction. After finishing with limits, we have to do the derivative in order to do the table of variation. Again, It's ln x. What is the derivative of ln x? I just did it, right? Which is 1 over x ln x. And this is strictly positive number. This means that the function of, because the numerator is a constant number, it's positive, and down is positive according to the domain. So the function is strictly increasing function. And then table of variation. Table of variation, we start from 1. Be careful. From 1 this time. Open at 1. It's not from 0. To plus infinity. We don't have any point that makes the between 1 and plus infinity that makes the derivative equal 0, because derivative has one constant number in the numerator. So the derivative in this case was strictly positive number, and the function was strictly increasing. And limit at 1, if you can go back, limit at 1 plus was minus infinity, and this is 100% true, because it was from minus infinity up to somewhere. Limit at plus infinity, it gives me 0, right? And this abscissa axis, x-axis, is an asymptotic direction. We're done. We're almost done. Let's see if we have some particular points. Taking y equals 0. This means taking the function ln of ln x is equal to 0. And we all know that ln 0 is equal to 0 is equal to ln 1. What's that mean? If taking ln from both sides, we got that ln x is equal to 1. Taking this ln from here and this ln from here, so what left is ln x is equal to 1. And 1 is ln e. Taking again the ln from here and ln from here, that gives us that x is equal to e. That's great. X is equal to e. We can we have so a point, right? Let's say it's point A of abscissa e and ordinate 0. That's really great. We can take another point like e square if you want. Let x equal e square. If you want some particular points, we can do that. So this will be, y will be ln of y. I took e. We had e, so I took another one, which is e square. This one is easy because this will be equal to ln. What is ln e square? It's 2 ln e. And ln e is equal to 1. So what left is ln 2. Right? Another point of abscissa e square and ordinate ln 2 if you want to have more specific points. And that's it. We can now directly draw. Let's see if I have time to draw. We have time. Let's do it here before I do it on the calculator, on the math calculator, right? But the problem here is really hard to draw. Anyway, this is the y-axis. Let me do it fast. This is the x-axis, and if you remember, we have x equal 1 as a vertical asymptote. You can go back and see y equal 1 is a vertical asymptote. So this point is abscissa 1 at abscissa e, which is 2.718 something, right? Somewhere over here below 3. Y was 0. This is point E, and simply the curve. This is point A, right? This is point A, and there's another point B somewhere, right? Which is e square ln 2. You can find it by calculator, and simply it goes from minus infinity to the asymptote 1 all the way, cutting the x-axis at the point I did already put, which is A, E0, and it goes asymptotic direction, which is the x-axis. It's clear that we have to, this is asymptote near to it, and it goes up, 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 cutting the x-axis, passes through this point, and it goes all the way like parallel, as if it goes parallel to the x-axis, but it ran away from it, right? It ran away from it. This is the curve. Simply, this is the curve. I don't know if you have time, but let me do it fast here. Okay. It was ln x, right? It's ln of ln x. That's it. Graph it, and let me see it here by the worksheet. Okay, it's not that clear because, okay, let me see it here. Let's see. All right, is it clear now? It goes from, they're not using the asymptote, but the asymptote is here, is at x equal 1, and it goes all the way up, and then it